Hi, hello guys, this is JK Max. Welcome back to my channel. Today we will see the real numbers first chapter. In that we will see all the sums in the first exercise. So let's jump into the video. Don't forget to subscribe my channel and share this video to all authentics. So let's jump into the video. So first sum. Express each number as a product of its prime factors. So here we have to do is 140. The first subdivision is 140. So what we should do is we should split this number into small numbers like prime factorization. Let's see how to do it. See, what they are asking to do is express each number. That is, we should express the 140 into splitted form. Means, let's see. Okay, so this is called prime factorization. To do this, we should put like this and we should insert the number inside it. So now to do this, we should use only prime numbers to do the prime factorization. So what are the prime numbers? Let's see. 2, 3, 5, 7, 11, 13 and so on. So now for prime factorization, the rule is to use only the prime numbers. So we should divide this only using our prime numbers. So let's divide. So let's use 5, which is divisible by 140 is divisible by 5. So we are using 5. Also it is a prime number. So how much time it will go? 5 2s are 10, remaining 4 8 is are. So we are getting to 28. So let's use 7. 7 is also a prime number. 7 4s are 28. Now we can use 2. It's a prime number. So this is called prime factorization. So 140 prime factorization is equal to 5 into 7 into 2 into 2. This is called prime factorization. So we have expressed 140 into 5 into 7 into 2 into 2. So we can also write like this: 2 square into 5 into 7. This is the prime factorization of 4. That's it. Now let's see the next sum. Now 156. We should express 156 in prime factorization. So let's use 3. It is also prime number, obviously. So 3 5s are 15, 3 2s are 16. Again we can use 2 table. 2 2s are 4, 2 6 are 12. Again 2 table, 2 13s are. So 13 is a prime number. We can't divide it with using any numbers. So we should leave it as it is. So 156 is expressed as 2 into 2 into 3 into 13. So this is the prime factorization of 156. It can also be expressed in this form. See, 2 square into 3 into 13. You can also check whether this number comes as prime factorization by multiplying all the numbers. See, 2 squares 4, 4 3s are 12, 12 into 13, 156. So we are getting the number. So let's go to next sum. Now 3825. So since the last units digit ends with 5, we can use 5 table. 5 ones are, you can do in a notebook. 5 6 are 30, 5 7s are 35, 3 remaining, 6 are 30, 5 5s are 25. So again it ends with 5. So again we can use 5 table. 5 ones are 5, 5 5s are 25, 5 3s are 15. Now we can use 3 table. 3 5s are, so I don't have space, I'm doing right side. 5s are 15, 3 ones are 3. Now again you can use 3 table. 3 ones are 3, 3 7s are 21. See, we are getting 17 as last one. 17 is also a prime number, so we can't divide it. So this is the prime factorization, that is 3 into 3 into 5 into 5. So this is the prime factorization of 3825, that is 3 square into 5 square. you can check whether number comes or not by just multiplying these numbers. So 3 square 9, 9 square 9 into 5 square 25, 9 into 25 gives you 3825. That's there. So next two sums you can try on your own. It's a very easy sum. Let's jump into another sum. This is the second sum in the first exercise of real numbers. So let's see. Find the LCM and HCF of following pairs of integers and verify that LCM into HCF is equal to product of two numbers. So here we should find the LCM and HCF of two numbers. Here they are given two numbers. First subdivision 26 and 91. So two numbers. We should find LCM and HCF of each of the numbers separately, and we should check whether LCM into HCF is equal to product of two numbers. So what they are asking is to first we should take the LCM and HCF of both the numbers separately, and then we should multiply them, and we should prove that this product is equal to product of two numbers, that is 26 and 91. 26 and 91. So we have to prove the same one. So let's see how to prove it. So LCM is nothing but least common factor and HCF is highest common factor. So I'll give you a simple trick which makes your calculation very easier manner. So this trick won't work anytime. So this is a simple hack. I'll teach you how to do it. So let's see. So first sum 26 and 91. So first we shall find the LCM of each number. So first we should do the prime factorization of each number. That is 2 13 is a prime number, we can't divide it. Let's go to 91. 91 we can take 7 table, 7 ones are 7 3 13, again a prime number. So prime factorization of 26 is 2 into 13 and 91 is 7 into 13. So now I'll teach you how to find LCM and HCF. For LCM we should see the that is least common factor. So we should see the highest power. So we can see here, first I'll teach you HCF. HCF is highest common factor. In the both the numbers we took prime factorization. Now check which number is common on the both the sides, both the numbers. So 13 is common. So we should circle it. So it's the common for both the numbers. So 13 is HCF. So HCF is equal to 13. Okay. In the abbreviation we are saying that highest common factor. So we should find the common number which suits both the numbers. That is 13 is common number. Now let's see LCM. LCM is except the number. Since the HCF is 13, we should take LCM all the numbers. See, for LCM we should take 2 into 7 into 13. So this is LCM. I'll show you a different color. So this is LCM. 2 into 7 into 13. 2 into 7 into 13. So this is called LCM. Hope you understand. That is HCF is LCM is equal to 7 into 2 into 7 into 13, which is nothing but 182. HCF will be 13. So it is easy to find HCF in any of the question, but LCM will be little tough. So I'll teach you how to make it. So let's go to next sum. Now let's see the second subdivision 510. So let's take the prime factorization of 510. So it is a time taking task, so you should practice for more speed. So what is the prime factorization of 510? Let's see. So for 510 we can take 5 table first. 5 ones are 5, 5 twos are 10. sorry 0 and 2. Okay. Let's take 2 table. 2 5s are 2 1s are 3 table. 3 1s are 3 7s are 20. 17 is a prime number, so let's not divide it. So 510 prime factorization is 2 into 3 into 7 into 5. 1 second. 2 into 3 into 7 into 5. So this is the prime factorization of 510. Now go to 92. 92 is 2. Let's take 2 table. 246 are again 2 table. So 23. So 23 is a prime number. Yeah. So prime factorization of 92 is 2 into 2 into 23. For 92 we can write like this also. See, 92 is equal to, so there are two 2's, so we can write it as 2 square and 23. Okay, now let's find LCM and HCF. First we can see HCF. For both the 510 and 92, which prime factorization we have taken prime factorization, so which is the common number in both the prime factorization? So 2 is there only. In 510 we have only 1 2, and here we have 2 square, so only 2 is common, 1 2 is common, so let's circle it. So only 1 2 is common, so HCF will be 2. HCF is equal to 2. See, you may get confused. Let's see, 92 is equal to 2 square. Once again, see, 92 we can write it as like this. It depends upon your comfortable. See, now to find HCF, which both the prime factorization must have a common factor to find HCF. So here we have common factor only as 2 common number, so let's circle it. So 2 is the HCF. HCF will be 2. Now to find LCM, the middle part is taken off. Now let's go to LCM. So for LCM we should take all the numbers, that is 3 into 7 into 5 into 2 into, except the numbers which we have circled. So in circle we should take only the one number, that is A2, only 1 2. See, the prime factorization of 510 is 2 into 3 into 5 into 70. For 92 is 2 into 2 into 23. So this is the prime factorization we got. So now to find HCF, we should say common factor, common number. So here in both numbers we have a common number as 2. So this will be your HCF. To find LCM, here 92 we have two 2's, both the 2's. So we can write it as 92 we can write it as 2 square row, 2 square into 23. So we can write like this also. So to find LCM we should see the highest power of a number. See, now this is the thing. Let's see these two part. I have made a rectangle, so let's see. So to find LCM we should see the both the terms, both the numbers we have 2 as common. For HCF we should see the lowest power, that is 2 square. Here to 92 we have 2 square, here we have only 2, only 1 to 2 power 1. So we should take 2 power 1 as a HCF. For LCM we should take highest power. Here among square and 1, which is highest power? So square is the highest power. So let's take 2 square and we should take all the remaining numbers. So this is the LCM. So LCM will be 2 square into 23 into 3 into 5 into 17, which will be equal to 23460. Sorry, 23460. So this is the LCM. So sorry, wait for a second. I'm sorry, literally I'm sorry. So this is the LCM of second sum. Yeah, we got it. So this is the LCM. Okay, it's the easiest sum. So I'll say simple trick. It's not that bigger. See, for suppose we have, let's take two numbers 4 and let's say 16. Okay, 4 and 16, these are two numbers. So for 4 which the prime factorization will be 2 square, right? Yeah, 2 square. For 16 the prime factorization will be 2 power 4. Am I right? Yeah, yeah, 2 power 4. For HCF we should see the lowest power. Lowest power means uh, the number which is smaller than the highest power. So here highest power is 4. So we should take the lowest power, which is 2 square. So lowest power is the lowest power we should take it as HCF. We should see the both common numbers in both the prime factorization as well as the lowest power. So here the lowest power will be 2 square. So HCF will be 2 square, which is 4. Okay. For LCM, we should see the highest power. Highest power means 4. So LCM is 4. Sorry, 2 power 4. We should not leave as it is. We should multiply it. That is 16, and this is 4. So for HCF, we should see the lowest power. For LCM, we should take the highest power of the number. For HCF is another thing. We should see the common numbers, and then we should go for the power. For HCF, that is lowest power. For LCM, we should go with highest power and all the remaining numbers except the numbers which we took for HCF. That's it. So third sum you can try. It's easiest sum. So let's go to another sum. See, now let's check for this. So in question they have given that we should prove this and this. LCM is equal to product of two numbers. So now let's see. For second one we have done that. So for LCM and HCF, what is LCM? LCM is 23460. This is the LCM, and HCF is HCF is 2. HCF is 2. So this is the first LHS. Now let's go to RHS. This is let's take it as RHS, product of two numbers. So equal to 510 into 92. So we should prove this and this equal to. So see, let's see. So you can multiply and see whether it is right or wrong. So the answer will be 510 into 23460. Answer will be 46920. Yeah, 46920. 510 into 92 is also equal to 46920. So this is the answer. Both LHS and RHS will be getting the same answer after multiplying both the numbers. So LHS is equal to RHS. Or we can write like this also, LCM and HCF is equal to product of two numbers, hence prove. That's it. So this is the easiest sum. Let's go to another sum. Find the HCF of following pair of integers using the prime factorization method. So in previous sum they told us to find both LCM and HCF, and we should prove that product of two numbers is equal to LCM and HCF. So now we should find only HCF, which is the easiest one. So let's see. For 135 we should use only prime factorization, otherwise your teachers will cut the marks. So let's see. For prime factorization of 135 is let's check 5 table. 5 2s are 5 7s are 3 table, 3 9s are 3 3s. Okay, this is the prime factorization. Okay, now let's do for 225. 225, let's take 5 table. 5 ones are 5 4s are 20, 5 5s are 5 9s are 3 3s are. Okay, we have got the prime factorization. Now let's check it. So for 135 the prime factorization is 5 into, there are 3 times 3 is there, so we can write as 3 cube. Okay, now for 225 3 2 times 3 is there, and 2 times 5 is there. So in both the prime factorization we can see 5 and 3 as both the common numbers for both the numbers of prime factorization. So now let's go for the power. So what I said, for itself we should take only the lowest power. So we should take only the lowest power. So 3 we have common, 3 and 5 both are common here. Let's see. So 3 is common here and 5 is common here. Now let's check the power. Okay, so for 3 the power is 3 and 2, the lowest power is 2, so take it as 2, that is 3 square. Next we should see for 5. Here the lowest power is 1, so 5 power 1, so this will be your HCF, that is 3 3s are 9 and 5s are 45. This is the HCF. We should take, since both the numbers are same, we should see for the lowest power of the number. Here the lowest power is 3 square. Square is the lowest power, then 3 cube. Here 5 power 1 is less than 5 power 2. So this is the answer. Next two sums is a complicated sum, so you can just find it by prime factorization method. It will take some time, so you should practice that to attain your speed and accuracy. So let's go to another sum. Let's go. So fourth sum, given that HCF 306, 657 is equal to 9. So we should here find the LCM of 306, 657. It's the easiest sum in the whole chapter, real numbers. So let's go. Let's do it. So what they are saying is 306, 306 and 657, there are two numbers. So the HCF of both the numbers is equal to 9, which is given by the question. So we should find LCM. LCM, what is LCM? So I'll teach you a simple formula which will be useful for this type of questions. Let's go. Okay. So In previous sum, in second sum I think so, we have proven that LCM into HCF is equal to product of two numbers. Am I right? Is equal to product of two numbers. So this is the thing we have proven in second sum. So this is the formula which we have to use for the same sum. Okay, this is the big formula. Note it down. Let's go. So here we have got only HCF and two numbers. So let's apply the formula. Simple sum. So LCM we don't know. So let's leave it as it is. Into 9, which is HCF. It is given. So product of two numbers. Two numbers are 306 and 657. That's it. So LCM is equal to, take the 9 to that side, 306 into 657 by divided by 9. So this will be your LCM. So the answer will be 22338. So this will be your LCM. The only thing you have to remember is that formula LCM into HCF is equal to product of two numbers. Once you remember this formula, you can do the sum in an easier manner. So let's go to fifth sum. Check whether 6 power n can end with digit 0 for any natural number. So they are asking that the prime factor 6 power n, that is 6 power any number like 2 or 3, 6 power anything. So 6 power n, whether it can end with 0 or not. That is for suppose take an instance, 5 into 10 gives you 50, so it ends with 0. So they are asking that whether the 6 power something, whether it ends with 0 or not. For example, 10 square is 100, it ends with 0. So it's a thing. So this the same thing we have to prove this for this one. So 6 power n, can it end with 0 or not? That is the question. So now let's go. So the answer will be, if the number 6 power n for any natural number, if it ends with 0, then it would be divisible by 5. That is nothing but if the number ends with 0, it must be divisible by 5. For example, 10 square is 100. We can divide it by 5. Yes, sir, right? So 100 is divided by 5. So 5 20s are 100, gives you 100. So it is divisible by 5. But 6 power n can be divided by 5. So let's take 6 power n, 6 can't be divided. 6 square 36, 6 cube, no, 216. No, 6 power n cannot be divided by 5. So it's not possible. That is, prime factorization of 6 power n would contain the prime factor of 5. That is, if it has to end with 0, it should be, the prime factorization should contain at least 5. So the prime factorization should contain 5. So that's a rule. This is not possible because 6 power n, that is okay. So 6 power n, the prime factorization of 6 power n will be 2 into 3. That is 2n or something. 2n into 3n. That is the prime factorization of 6 power n. Okay. So only prime factorization of 6 power n contains only 2 and 3, but not 5. Since it does not contain 5 as a prime factor, it cannot end with 0. So since it cannot end with 0, the given question is a wrong one. So for any number to end with 0, it must contain a 5 as its prime factor. So for example, 10. Let's take 10 as an example. So what is the prime factorization of 10? That is 2 into 5. It contains 5. So it can end with 0 and can be divided by 5. So it can end with 0 as it last. Now take 4 prime factorization of 45. Sorry, 40. Prime factorization of 40 gives you 2 cube into 5. So 2 cube into 5. Since it contains a 5, it can end with 0. So it can be divided by 5, and the last number will be 0. That's it, the answer. You can write it in a simple sentence as you want with your thinking. Let's go to sixth sum. The question: explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. So composite number is nothing but a number which has more than 2 prime factors. Uh, so let's take a prime number. 7 is a prime number. Once again, 7 is a prime number. So prime factorization of 7 is 7 into 1. So only two numbers are its prime factors. This is a prime number. That's why we are saying 7 as a prime number. But for take instance for 9. So 9 we have 3 square into 1, and 3 into 3 into 1. So it has more than two prime factors. Since it has more than two prime factors, we can say 9 as a composite number. Composite number is nothing but a simple matter. It has more than two prime factors. If it does not contain more than, it contains either two prime factors or less than two, we can say it as a prime number. So prime number contains prime factors as a number itself and one as its prime factor. That is 7 itself and 1. Only two prime factors. But in a composite number, there are three prime factors. 1 into 3 into 3. So this is a composite number. This is known as composite number. Now let's go see the sum. So they are asking why this number. So the question is they are asking why this number and this number are composite numbers. So what we should prove? So we should prove that why this number and this number has more than two factors. That is two prime factors. So let's prove. Okay. So let's see. So first number 7 into 11 into 13 plus 13. So we can write this number as like this also, right? See, 7 into we can take 13 as common one. So we can write like this: 13 into 7 into 11 into 1 plus 1. Since we have taken 13 as common, we are writing the in place of 13 we are writing 1. So 13 into 7 into 11. Okay. So this will be equal to 13 77 plus 1. That will be equal to 13 into 78. See these two numbers. For this we have more than two prime factors, that is 78. So let's take prime factor of 78. It will be more than two prime factors. 30 2 3 are 6, 2 9 are 18, 3 13 are. So the prime factor is so the product of two numbers has more than two prime factors. That is 13 into 2 into 3 into 13. So this is the prime factor of 78. So if we multiply 13 and 78, we would be getting a large number which has more than two prime factors. So that is why we should proved as a composite number. That's it. So now the next number. Again 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So this is the given number. So here we can see again 5 as a common number. See, we should see the mathematical sign. Okay, so here it is plus. Okay, so 5 is common factor of both mathematical sign. So let's take 5 as common thing. Okay. So let's take 5 as common. So 7 into 6 into in place of 5 we are writing 1 since we have taken 5 as common one. Into 4 into 3 into 2. I am just copying the question as it is, but in place of 5 I am using 1 plus 1. So you have taken 5 as common thing out of the bracket. So let's see, multiply and see it whether it is a composite number or not. Wait for a second. Yeah. So 5 into, if you multiply all these numbers, we will be getting if we multiply all these numbers and add with 1, we will be getting 5 into 1009. So this is the number. So if we multiply both of these numbers, we will be getting again a large number which has more than 2 prime factors as it prime factorization. So let's see what we'll be getting. See, 1009 is a composite number which has more than 2 prime factors. If we multiply 5 into 1009, we'll be getting again a large number. So it has more than 2 factors. More than 2 factors means it is a composite number. So hence we have proven. Let's go to another sum. Last question of this exercise. So the question is, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round on the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Here there are two characters, Ravi and Sonia. So there is a circular path. Yeah, there is a circular path. There's a circular path. First, here is Ravi, and here is Sonia. Both at the same point. Okay, both at the same point. Wait for a second. Ravi and Sonia, both at the same point. If they both start running at the same circular path, if Sonia takes just 18 minutes to complete the track and Ravi takes 12 minutes to complete the track in the same direction, if they run, after how many minutes they meet again? That is, after how much time they will meet again at the same direction, means at the same point. See, again this is the point. After how many minutes will they meet at the same point? That is, after how many minutes? Sorry. So Ravi and Sonia start at the same point. Ravi takes 12 minutes, Sonia takes 18 minutes. So they're asking after how many minutes will they meet at the same point. So first we can find LCM. Sorry, prime factorization. 18. Let's take 2 table. 2 9s are 3 3s are. Now for 12 they are 12. 2 6 are 3 2s are. So 18, the prime factorization of 18 is 2 into 3 square, and 12 will be 2 square into 3. So this is the prime factorization. So here many students will have a same doubt, that is it's whether we should find LCM or HCF. So let's see. If you see, as expected, many people will have a doubt in this sum whether to find LCM or HCF. Not only we people, many students have the same doubt. So let's get it out. So this is the prime factorization of two numbers. Let's see. So I'll say a simple trick. If you find any of these sums like related to time or something, or any field circular path, if you see these keywords like time, minutes, sports field, circular path, you should say directly that we should find LCM. LCM is the only thing we have to find for this type of sums which contains circular paths, force field, minutes. So for this type of questions we should find only LCM. So LCM, how to find LCM? We will take the highest power of both the numbers. So here 3 and 2 both are common. So let's go to the power. For 3 which is the highest power, 2. And for 2 which is the highest power, 2 square. So 2 square, 3 square into 2 square. This is the LCM. It is 36. So for units we should write the minutes. So this will be the answer for this question. So this is the only thing that we should see the keywords, that is circular path minutes. For this type of sums, if you see 2 times, that is 2 people starting at the same point, and after how many minutes they will reach the same point. If they ask like this question, you should say directly that we should find LCM only. You should not have a single doubt about this. It's for using these keywords you should find only LCM. It's a simple thing. So after finding LCM, we put these minutes at its units, my units. So without that, you will be taking a half mark. So you will be losing half mark or 1 mark. So we have finally completed the exercise. So tomorrow let's see second exercise. Thank you. Bye bye. Subscribe to my channel and share it.